All right, we're back with surface area of rectangular prisms. With me, it's Mr. Hain. All right, so the central question for today is what does surface area mean? So this is a little bit of a review for some people, and this is a review definitely for 8th grade. But I just wanted to touch on this before we dived a lot deeper into what surface area is for different types of shapes. And so our central question for today is what does surface area mean? All right. So if we take a look of a net of a box, and I have a rectangular prism right here, what it's going to do is if I were to fold this up on all the dotted lines, I would get a rectangular prism, or like a box or a chest. I've had students call it a Minecraft chest, but it's just a chest. So here is my quick and dirty drawing of what each of those parts are. So you see the bottom and the top are both 2 by 3. The front and the back are both 2 by 6. That's this one right here. And the top and the bottom are both 6 by 3. So if I just multiply those together, I have the top, the top here for 6 times 3 is 18. 2 by 6 is the front, and 2 times 3 is the left-hand side. So that's only one of each of those sides. So I add them up, I get 36, and then I take that number for the areas, and I multiply it times 2. And that's going to give me 72 centimeters squared. Okay, so there's some people that are like, yo, Mr. Hain, this is a three-dimensional figure when you fold it up, and yet here we only have a squared instead of a cubed for the units. Now, the big deal is, as you see, we can unfold it flat, because when we're finding surface area, we can always fold something flat, so it's just 2 dimensions. I'm also dealing with just length and width. I know length, width, and height come up, but when I fold it all the way flat, it's just a 2-dimensional shape. So I'm adding up all of the areas for each of those 2-dimensional shapes parts, each of those rectangles, adding them up, and then multiplying them times 2 to get my total surface area. All right, so let's move right on to another example. This one has decimals in it. It looks a little bit different, but you see the left and the right sides of that box are just in different places. And I can still do the exact same thing. So I'm going to find the area for each of those boxes. 3.1 times 5 gets me the left and right sides. 3.1 times 7.4, 3.1 times 7.4 gets me the front and the back sides. And 5 times 7.4, that gets me the top and the bottom of that rectangular prism. So I'm going to add those up, and I get 75.4. Remember, as always, that I am shortcutting after the first slide. That's because you need to show the work on your paper, or if you're doing this at home, obviously you're doing the work on your paper. And the 75.4 is just for you to check what your work should be and what your answer should be along the way. So if you remember from what to do in the previous slide, you'll already have your answer. I'm going to take a sip of water, and you can find that answer. You multiply times 2, and your answer would be there. So I'm not going to show that answer, but you can absolutely check yourself with a calculator. Skadoosh. So let's derive the surface area. I've talked a lot about what this means, but when I take this rectangular prism and then I unfold it flat, the red and the 2 red parts at the top and the bottom of that box, and you see a lot of the measurements have been labeled. So I have a top and bottom, left and right, and front and back side. That means there's 3 pairs of sides that are congruent. So 3 congruent pairs of sides. All right, so what that means is I can take, and what you've seen me doing so far in the video without actually just showing it, is the top of the rectangular prism is found by multiplying length times width. The left side is length times height, and the front side is width times height. So all I have to do is take length times width plus length times height plus width times height, which is here, and multiply times 2. And that is the formula for the surface area of a rectangular prism. This is so important, I think you should pause the video and write this down. I'll be back in a moment after this beautiful sip of water. Yep, you can also pause the video and see if you can find the total surface area for this shape, which I am not going to show in the video, but you can just plug these numbers into the formula and that will pop out with the total surface area. Sweet. All right, so we can also find the surface area from figures now. So all we have to do is identify what the height, length, and width is, or height, width, and length. And once we have those, we can put them into our formula. Go ahead and pause the video. I think I actually showed the answer for this one. And we're back. I put that into the formula, and oh, I gotcha. There is no answer shown for this one, but you can put those numbers into the formula and find it. If you're in a classroom, go ahead and take a hand if that person has shown their work on their notes. This one was so amazing, you just have to get your work done because I actually have the answer popping up with it. So the point for this slide, especially if you're at home, is to show all of the work to get 819.5 centimeters squared. So go ahead and pause the video and make sure you get that work. And then when you have that work done, which is not going to be shown in the video, you should see that if you plug that into your calculator, you get the same answer as me, which is 819.5 centimeters squared. And we're back. So if you're done, go ahead and write that summary. Make sure your table of contents is updated if you're in my class, and if you're not and following along at home, just keep doing the math.